Ooh, you're going to find the length of the curve. Ooh, this is exciting stuff. Find the length of the curve. Okay. That doesn't seem like calculus. Look, I made a triangle. 1 to 7 is 6. 1 to 5 is 4. This distance here is 4 squared plus 6 squared equals something squared. So that's 16 plus 36 equals something squared. So the something has to be, okay, that's 46, 52. The square root of 52. I did it. Oh, now how would you use calculus to do this? Okay, so we need to use calculus. We want to find the length of that curve. So when I think calculus, I think of adding things up. So what if I thought of a whole bunch of tiny little triangles? And I added all of that up. So like each of these triangles, let's do this. Move. Each of these triangles, I'm going to think of as, this is a little change in x and a little change in y. So this unknown piece here is the square root of delta x squared plus delta y. I might need to put parentheses, that might be better, squared. And that reminds me of Riemann sum stuff, so add that up. But I want to think of integration stuff, because that's where we've been living. So when I think of integration stuff, it would be great to have a delta x separate, because that's like my dx. So let's see if we can get that delta x out of that square root. And really, you should pause the video right now and see if you can do some algebra to get that delta x. You want to have some stuff and then delta x. See if you can play with that. Pause the video and see if you can go from there. Okay, so hopefully you paused the video and you came back. If you were stuck, I'll try to slowly do some steps. So our goal, here's what we want to do. I want to take this, get this out of here. Our goal is to take the square root of delta x squared plus delta y squared and get the delta x out here. Because if I do that, then my life is way easier. So let's see. As I said, I'm going to try to do these steps slowly. What if I did this? What if I put a delta x out here? Because I want it there. But so I don't break the rules, what if I put a delta x here? If that gives you an idea, you should pause the video and see if you can roll with that. If it doesn't, keep listening and pause when you are ready. Okay, so if I slide that delta x underneath the square root, if I write that as a big square root, I still have delta x squared plus delta y squared over delta x squared, because when it comes inside, it needs to be squared. And I'm actually going to cheat. I'm going to give each of these that. Delta x squared, and then I have a delta, not a dx, not there yet. I have a delta x. Got it. So now, I think I see it. And if you see it, cool. That's going to be 1. And that's delta y over delta x squared. Ooh. That's like a Riemann sum way of writing things. But I could also use an integration symbol for that. So I could write an integral and a dx. I'm slow playing this so that you're hopefully thinking and trying to figure out what the heck I'm going to write there. I'm going to put the square root. That's still going to be there. I'm going to put the 1 plus. You should recognize that delta y over delta x. Another way of saying that would be dy dx. Oh, so it's just a derivative. And I bet we go from like a to b. All right, let's see if it works. We just did some stuff. Let's see if we can do this. That line that we started with, the slope of that line was up 4 over 6, so it was 2/3. So we gotta get to a tool that will let me write. Integrate square root 1 plus 2/3 squared. Don't forget to square things. I always forget to square that thing, and that gives me trouble. My a to b was 1 to 7. So let's go 1 to 7. 2/3 is 4/9 when I square it, and 1 is 9/9. So 4/9 and 9/9 is 13/9. Square root of 13/9 dx. All right. So whose derivative is that thing? That's just going to be the square root of 13/9 x from 1 to 7. And then plug in 7, plug in 1, so that's going to be times 6. I don't want to shrink things, so I'm just going to write times 6. If I write that as the square root of 13 over the square root of 9, but the square root of 9 is 3, so that's the square root of 13 over 3. 6 over 3 is 2. That's 2 square roots of 13. If I use my magical understanding of simplifying square roots, that's the square root of 4 times the square root of 13. Square root of 4 is 2. Oh, I got the same thing. So to find the length of an arc, it seems like I just do this square root thing with the derivative, and I can find the answer. Let's check that out here. So suppose I want to find this. I'm going to go this length, because I don't know what that other number is. I could figure it out, but I don't feel like it. So my curve is going to be negative x squared plus 2. I guess I could find out what that 0 is. Don't feel like it. It's the square root of 2. So I want to figure out that length. So dy dx is negative 2x. And we just figured out that all we got to do is integrate. I'm going to go from 1 to 2. I'm not going to go from 1 to 2. I'm going to go from 0 to 2. Wacky dacky. Square root 1 plus negative 2x squared dx. Now, the fun part about some of these is we don't know how to do some of the integrals that we're going to be asked to do here, so we have to use technology. So if we do 1 plus 4x squared inside a square root, I typed 3. From 0 to 2, I get 4.64, I'll call it 7, as my approximate length. We could see if we're in the ballpark, right? This is 4 and this is 2, so 4 and 2. That'll make 16 and 4, which is the square root of 20. So somewhere between 4 and 5, closer to 5. Sure, that makes some sense. If you're confused because the square root of 20 is actually closer to 4, I forgive you. Don't forget that that square root of 20 is actually an underestimate because we've got this curvy part, not just this line part. So 4.6 makes some sense. All right, hopefully that makes some sense.